Right. So in the previous few videos, we talked about convergence and divergence of an infinite sequence. Now, we can also extend this concept to series as well. Okay, so I'm just going to write it over here and show you what's the difference between. Okay, so whenever we talk about convergence and divergence of a sequence, right? So the difference is basically like that. So for sequence, we are only concerned with as n approaches infinity, right? What does my general term? So as n approaches infinity, if my general term approaches a specific value, then it will be a convergent sequence. Now for series, the concept is the same, right? As n approaches infinity, what does the sum of my terms approach? So that's the difference between them. But the concept is more or less the same. For a series, right? The idea behind it is there is got to be a formula to begin with for a series. So, for example, I'm just going to write here. For example, let's say given that the sum of the first n terms in a sequence, which is essentially a series, is given as n squared n plus n, right? For example. So, as n approaches infinity, right, we can see that my sum of the first n terms will approach infinity as well. So therefore, it's not convergent, right? It's not convergent because it does not converge to a, right? Or rather, you can say that there's no limit, and there is no limit. And since that there is no limit, that is not convergent. And since it's not convergent, that's basically the same concept as before, right? So just know that this concept can be extended to series as well, and not only just restricted to sequences, right? If not, that's it. We are going to be practicing the concept of convergence and divergence of infinite series. So as mentioned, this concept can be applied to both your sequence as well as your series, as long as they are infinite. So over here, we are given three different series equations, and we are supposed to determine whether they are convergent or not, and state the sum to infinity if it's convergent. Now, in case you're wondering, what is this sum to infinity? So for sequences, right, when you have a limit of n approaches infinity, right, as n approaches infinity of un, you get this thing called the limit, right, which is the value that the generator tends towards. But for series, right, as n approaches infinity for a series, we don't call it a, we call it a sum to infinity. So it's literally the same thing. It's just that we call it differently. Okay, so for the first one over here, right? Is it convergent or is it not convergent? So if you take a look at the n values over here, right, you can see the n is in the denominator over here and the n over here is in the denominator. So you ask yourself, as n approaches infinity, what happens to Sn? Right? You know that 6 will be still 6, right? The 6 will change. But then 1 over n plus 1 will actually tends towards 0 because your denominator will become very, very huge, right? Same thing for 1 over n plus 2, it will actually tends towards 0 as well. And I'm going to bring this whole thing to the bottom over here. So out of the three terms, right, 2 of them will tends towards 0. That means the limit of n approaches infinity, right, where of a Sn is as good as saying, the limit of n approaches infinity for 6 minus 1 over n plus 1 minus 1 over n plus 2. So we know that this will tends towards 6, right? Because it will become 6 minus 0, which is 6. So the answer is yes, right? Yes, it's convergent. It's convergent because the value eventually converts to one specific value, which is right? It doesn't blow up. It just converges to one specific value because the rest of the other terms, they tend towards 0. And we don't call it the limit, we call it the sum to infinity is 6. Okay, so it's the same concept, it's just calling it, right? But this is specifically for a series. Now for B over here, right? Fn equals to, what's that? N squared plus 2n. Now over here, what happens to the n terms as n approaches infinity? As n approaches infinity, you know that n squared will approach infinity as well. And 2n will also approach infinity, right? So therefore, as n approaches infinity, your Sn will approach infinity as well. And since it approaches infinity and not converge to a specific value, it is not convergent, right? And since it's not convergent, it means that the sum to infinity does not exist, right? So it does not exist for B because it's not convergent to begin with. Now, for the third part, which is C, right? Fn is obtained from a constant sequence. So what does that mean? So over here, indeed, how does a constant sequence actually look like? Right? A constant sequence can be one that looks like that, right? It can be one that, for example, 3, 3, 3, 3, 3, so on and so forth, right? Every term in the sequence is constant. So for this type of constant sequence, right, the sum, or rather, if this is term 1, term 2, term 3, term 4, term 5, right? Every term is the same. So as n approaches infinity, Okay, but first let's define what is the sequence, right? What's the formula? Just using this as an example. So Sn would essentially be 3 plus 3 plus 3 all the way until plus 3, right? How many times? N number of times. So it's as good as saying that you have 3n over here, right? Just using this as an example. So for example, because the question never provide us with examples, so I'm just going to use 3, 3, 3, 3, 3, 3. So you can see that as n approaches infinity, right, 3n itself will also blow up. And since it blows up and it doesn't converges, therefore, this is not convergent, right? It's not convergent for this example over here. And since it's not convergent for this example over here, then therefore, the S infinity does not exist for this example over here. But of course, there is also another case, which is a very unique case, whereby there is a sum infinity, right? So another example would be this, right? Another example, I can have a constant sequence where everything is 0, right? And my sum of the first n terms will essentially be 0 times n number of times, which will still be 0. So even for this case, right, even as n tends towards infinity, my sum to infinity will still tend towards 0. Because if I add an infinite number of zeros to them, it will still be 0. And therefore, the sum to infinity will converge towards 0. So yes, it's convergent. So for the last question on which it's actually 2 different answers, depending on how you see it. But if you are able to catch it, you'll realize that there's 2 different possible answers which are both correct. So that's it for this concept of convergence and divergence of definite series. Let me know if you've got any questions for this in the comments. If not, in the next portion, we'll actually be going through the more commonly tested type of sequences, which is your AP, arithmetic progression, and subsequently your GP, which is your geometric progression at the bottom. I believe it's somewhere over here. Yeah, but we get that. If not, that's it. I'll see you over there.